Okay, good day. This is Math 140 College Algebra. I am Professor McCulley, and this is lesson number 3.8, problem solving with quadratic functions. Let's get right to it. Today we are going to talk about using quadratics to solve some problems. And in general, when you're talking about that, they're going to ask for either the vertex, the x-intercepts, the y-intercepts as an initial condition, or doing some modeling to predict future results. So just some hints here, since there's no hard, fast rules. If the question asks for a maximum or minimum value, then most often they're asking for a vertex. If the question asks for an initial or starting amount, then most often they're asking for a y-intercept. If the question asks when the vertical axis is equal to 0, then most often they're asking for an x-intercept. Like if we have a projectile motion or something where it hits the ground, that's when the vertical axis will be 0. So pictorially, a lot of times you're going to see parabolas. Let's get a better tool here. Get a tool that I like. All right. You're going to get a graph that looks like this. And so there's a y-intercept. So y-intercept usually refers to initial condition. That's spelled right here. I-N-I-T-I-A-L. A vertex, usually, and here's our vertex for this one. So there's my y-intercept. And here is my vertex, some sort of maximum or minimum value. And then here is the x-intercept. All right, so some projectile motion equations in the practice work. There's some projectile motion. And so when h is in feet and time is in seconds, you're going to use h of t equals negative 16t squared plus v sub 0t plus h sub 0. When h is in meters and time is in seconds, you're going to get h of t equals negative 4.9t squared plus v sub 0t plus h sub 0. And I just have a couple real quick examples here. So first example, find two positive real numbers whose product is a maximum, and the sum of the first and twice of the second is 100. So right off the bat, they're asking us to find a maximum product. So in general, we're going to be looking for a vertex for that particular one. And so positive real numbers, so I'm going to say x and y are my positive real numbers. And we are trying to maximize product. Product implies multiplication. Now I know that this, oops, I should have had a y there. Sorry about that. We'll fix that. X, Y, product, we're maximizing product there. And so in general, if you had no other constraints, you couldn't really maximize product. You just keep picking larger and larger positive real numbers. That being said, these two values have a limitation on them. And that limitation is that the sum of the first and twice the second is 100. So the sum of the first, so x plus 2 times y, is going to equal to 100. And so we couldn't have anything that's going to be outlandishly big. Like example, you could have 98 here and 1 there. And then we would have 1 times 98 would be 98. I don't know if that's the maximum product, but we're going to find it. And so this is my secondary piece of information. And so what I'm going to do is I'm going to use this secondary piece of information to get this down into a single variable. And so what I'm going to do here is I'm going to solve for x. And that'll give me x equals 100 minus 2y. And we could have solved for y. I just see that that's a little bit easier. And so now I'm going to take this and I'm going to do a substitution. And so I'll get p, and then P is equal to, it'll be 100 minus 2y times y. And when I multiply that out, I get P equals 100y minus 2y squared. And this thing is a parabola that opens down. And it looks like this. And this is y, and this is product. So right here is going to be my maximum product. So how do I find that? Well, you could use your graphic calculator, but we can also say that the axis of symmetry is going to be x, in this case y. Y equal to negative b over 2a. In this case, b is the coefficient of the linear term, which would be 100. So I've got negative 100 over 2 times a, which is negative 2. So I have negative 100 over negative 4, which would be positive 25. So since my y value is 25, they're not actually asking for the maximum product. They say find two positive numbers whose product is a maximum. So since I know that my y value is already 25, I can go back to this x value and say x is equal to 100 minus 2 times 25, which gives me an x value of 50. So when x equals 50 and y equals 25, the product is a maximum. All right, and the sum of the first and 2 times the second is 100. All right, next. If Professor Macaulay begins to shoot mackerel off the top of a building 200 feet tall using a mackerel cannon that propels fish at a rate of 100 feet per second, all right, so what else would you shoot with a mackerel cannon other than the mackerel fish? But what is the maximum elevation of the mackerel? All right, so right off the bat, we're going to go back, and it's feet. The building is 200 feet tall. So I'm going to start with this projectile motion. We're shooting fish. And since it's feet and seconds, I'm going to use this first one for that. So I'm going to go h of t is equal to negative 16 t squared plus v sub 0 t plus h sub 0. And we are given in the directions that v sub 0 is equal to 100 feet per second. And h sub 0 is equal to 200 feet. So I can go h of t equals to negative 16t squared plus 100t plus 200. And they want to know what the maximum elevation is. Well, the maximum elevation is going to again occur at the axis of symmetry. So I'm going to go t is equal to negative b over 2a, which in this case would be negative 100 over 2 times negative 16. All right, so I'm going to grab my calculator to do that because that's going to be a decimal. So 100 divided by 2 times 16 is 32. They were both negative, so I'm just going to do the positive. So it's going to take 3.125 seconds, 3.125 seconds to get to that maximum height. And I'm just going to take that and I'm going to make the calculation h of 3.125, which will be negative 16 times 3.125 squared plus 100 times 3.125 plus 200. So we'll make that calculation. H of 3.125 is going to be negative 16 times second answer squared plus 100 times second answer times, or not times, it should be plus here. Let's get it right. Plus 200. And that all looks correct. So 360 or 356.25 feet. So 356.25 feet. And so the next question is, how long does it take to hit the ground? So this is a time that we're looking for. Hits the ground, we'll have an h of t equaling to 0. So we're trying to find a time when it's equal to 0. I'm going to use the quadratic formula to do that. So I'll say t is equal to negative 100 plus or minus the square root of negative 100 squared minus 4 times a, which is negative 16, times b, which is 200. And that'll be all over 2 times a, which is negative 16. And so I'm just going to grab my graphing calculator again. We'll plug that in. So alpha y equals, to bring up the fraction, negative 100. And then we'll do plus second square root. And then it'll be negative 100 squared, but it's going to be positive anyway. Negative or minus 4 times negative 16 times 200. And that'll all be over negative 2 times 16 is negative 32. When I hit enter, I get a negative second, so that's what actually this one doesn't count. And then so I'll try, I just go second entry and I'll change that plus to the minus, and that's going to give us the one that we're looking for right there. Hit enter. So 7.82 or 844 seconds. 7.844 seconds. And just to be clear, this parabola opens like this, and this one was that negative one, and it doesn't count, so we don't worry about that one. All right, Professor McCulley is creating a pen to house his wild widgets. He has 100 feet of fencing and a side of a barn to create a rectangular pen area to house his widgets. What dimensions create the largest pen? And so I have a barn face, and then I am going to create my pen like that out of 3 sides. And so I have X here, I have X here, and we'll have Y there. And so the maximum area, we're trying to maximize area. So area is just length times width, in this case XY. And again, if we had no constraints on this, we couldn't maximize the area. But we know that 2x plus y has to equal 100. And so we have something similar to that first question. This time I'm going to solve for y and say y equals 100 minus 2x. And then I can go a equals x times 100 minus 2x. And then I'll have a equals 100x minus 2x squared. And when I find my axis of symmetry, x equals negative b, which would be negative 100 over 2 times negative 2. That'll give me 25. And so my x is going to be 25. My y is going to be 50. And so it's going to be 50 feet long, not log, 50 feet long. Do it again, 50 feet long by 25 feet wide. All right. Well, that's all I got for today, folks. So here is our Marvel fun fact of the day. The main antagonist of Ant-Man and the Wasp, his name is Ghost. In the comics, Ghost is a part of Iron Man's Rogues Gallery. That person is male in the comics and gets the powers from the suit, not the quantum realm. So they definitely changed the origin of Ghost, and in my opinion, it was for the better. Well, that's all I got for today, folks. Have a good day.